Hello there, everybody. Welcome back. So this video will cover review material for the November quarterly. And so the practice test that was posted, this video will go over that. So again, we're going to go over the practice test for the November 2020 quarterly. Again, this is just on the first half of the Unit 3A material. Okay, so question number 1 says what occurs when potassium reacts with chlorine to form potassium chloride. So the answer choices give us stuff about electrons and what type of bond it is. So at this point, we've only ever talked about ionic bonds. So it can't be B and it can't be D. And one of the things, even if we did cover covalent bonds, you could be like, okay, well, potassium we know is a metal, and chloride or chlorine we know is a nonmetal. So a metal plus a nonmetal is an ionic bond. And in ionic bonds, electrons are transferred. So an electron from potassium moves over to chlorine. So that means the answer has to be C, electrons are transferred and the bonding is ionic. Now, electrons are shared and the bonding is covalent, choice B. That is an accurate statement, but it doesn't answer our question. A covalent bond, just FYI, and we'll get to this in the next unit, is a nonmetal plus a nonmetal, and the electrons are shared. So we'll talk about what that means and what that looks like later on. But what you need to know for this, metal and nonmetal is ionic, and electrons are transferred. Okay, next, which elements react with oxygen to form ionic bonds? Again, ionic is a metal plus a nonmetal. We know oxygen is a nonmetal, so one of these four options has to be a metal. So calcium is a metal, hydrogen is a nonmetal, chlorine is a nonmetal, nitrogen is a nonmetal. So the answer has to be A. So even if we give you really weird named elements, you can still figure it out. It's still a very simple question. You just have to look at your periodic table. And again, ionic bond is metal and non-metal. Okay. Question number 3, element X reacts with chlorine to form an ionic compound that has the formula XCl2. To which group on the periodic table could element X belong? So you have to figure out what X is. And so you might be able to just figure this out in your head pretty quickly. But let's kind of break this down. So we have X and we have Cl. So in our formula, we have one X in there. So that's the number of it. And we don't know its charge. So we can put a question mark there so we don't get confused with the X's. But for chlorine, we have two of them. I'll write this down as the charge. So for chlorine, we have two of them, so that's the number. And we know the charge for chlorine is -1. Again, for nonmetals, even if you see a bunch of different numbers, you always pick that top number. So the charge for chlorine is -1. And we know that the overall charge of a compound is 0. So the plus stuff equals the negative stuff. So when we kind of work this out, we get 1 question mark plus -2 equals 0. So question mark minus 2 equals 0. Add 2 to both sides. Question mark equals +2. So that means something has to have a +2 charge. And again, that +2 charge means it loses 2 electrons. And while what group loses 2 electrons and has a +2 charge? That is group B. I mean group 2, answer choice B, rather. Sorry. Okay. Number 4 says an ionic compound is formed when there is a reaction between the elements. Again, ionic compound, we need a metal and a nonmetal. So strontium, which is Sr, is a metal. Chlorine, Cl, is a nonmetal. So that could work. Hydrogen is a nonmetal. Chlorine is a nonmetal. So it can't be B. Nitrogen and oxygen are both nonmetals. Can't be that. Sulfur and oxygen are also both nonmetals. Can't be that. So the answer, again, has to be A. So it doesn't matter what elements you get on in a question, if it's a metal and a non-metal, no matter what the name of it is, anything left of the metal-large staircase is a metal, anything to the right of that is a non-metal. So just make sure you check that. Okay. Question number 5, it says the bonds in BAO are best described as. Again, right now we haven't talked about covalent bonds, so don't pick covalent bonds. But in the future, that will be fair game. But Ba is barium, it's in group 2 and is a metal. O, group 16, we know is a nonmetal. So metal plus nonmetal gives you ionic. So there, again, we can get rid of A and B. And in an ionic bond, electrons are transferred. So that's just something that needs to go into your head. You need to remember metal, nonmetal, ionic, electrons are transferred. So moving on, number 6, it says the electron-dot symbol would best represent. Now, yes, it is written like this, and it's not the proper way to write it, but whoever typed this question up in the Regents was like, nah, I'm not about, making dots where they're supposed to be. So I typed up exactly as the question had it typed up. But anyway, the important thing is it has 2 valence electrons. So anything with 2 valence electrons is in group number 2. So Na has 1 valence electron. It can't be that. Mg has 2 valence electrons. Well, that's going to be our answer, but let's just keep going to make sure. Chlorine has 7 valence electrons, so it can't be that. And neon has all 8 valence electrons, and again, that can't be right. So don't get hung up on the fact that the dots are in the wrong places. Just focus that there are 2 of them. Again, if you were to do this properly, it would go like that. So even in general, when you're doing a dot diagram, you put your first dot on top, your second on the right, third on the bottom, fourth on the left, and then if you need to go around again, then you go around and do 5, 6, 7. So that's a little kind of side note in case you forgot how to draw a dot diagram. Okay, number 7, the correct name of the compound with the formula Pb2O is, so what we have to do, we have Pb, we have O. So we have to figure out what the charge of this is. So if you're looking at your periodic table, and the reason you know you have to figure that out is because Pb, which is lead, has a +2 version and a +4 version. So when your metal has multiple charges, you have to figure out which one it is. And that's what these Roman numerals are telling you. So we have to figure out if we're using +2 or +4. So what you have to do is, in our formula, we have 1 Pb. Because if you don't see a little subscript next to Pb, that means you have 1. And again, we don't know the charge of Pb yet, so we're going to leave that as an X. And then we're going to look at the oxygens. We have 2 oxygens in our formula. That's what that means. An oxygen has a -2 charge. Again, you always know the charge of your nonmetal. It's always that top number. So even if your nonmetals have a whole bunch of different numbers, it's always going to be that top negative number. In the case of oxygen, there is only one negative number. But for all of the nonmetals, it's always that top negative number. Okay, so with that, we know the compound has to have an overall charge of 0, so the total positive stuff has to equal the total negative stuff. So when we look at this, we have 1x, 1 times x is 1x, plus 2 times -2 is -4 equals 0. And if we neaten this up a bit, we get x minus 4 equals 0. And to get x by itself, add 4 to both sides. So you get x equals +4. So what that means is that we're using the +4 version of lead. And so in order to name that, that is why the answer is D. Because Roman numeral IV, that is 4, this tells you we're using lead with the +4 charge. And we can check that because you can be like, okay, Pb, this means +4. Oxide is oxygen, and we know oxygen has a -2. If we crisscross, we get Pb2O4, and then you just simplify it to PbO2, and that is exactly what the question is asking. So that's how you can figure that out. And again, if you see a shortcut, that there is a shortcut that works sometimes, not always. In this specific example, it does not work. But if you have picked up on that, that can help you. But this is just the longer way of doing stuff. Okay. Number 8 says which substance contains bonds that involve the transfer of electrons from one atom to another. So transfer of electrons, that we know is the definition of an ionic bond. Electrons are transferred, and it's between a metal and a nonmetal. So you have to go and look at each of these compounds and figure out what it's made of. C is a nonmetal, and O is a nonmetal. So two nonmetals, can't be that. N is a nonmetal, H is a nonmetal, can't be that. Cl and Cl, well, obviously they're both nonmetals, so it can't be that, which leaves us with C. K, potassium, is a metal in group 1. Br is a nonmetal in group 17. Metal and nonmetal, that is your ionic bond. Boom, you are done. Okay, number 9 says which type of bond is found in sodium bromide. Again, you don't need the formula for this. We just need to look at, what it's made of. So sodium is a metal. Bromide is talking about bromine, which is a nonmetal. And so now it's asking what kind of bond you have with a metal and a nonmetal. That is ionic. So again, we haven't got to this yet, but a covalent bond is nonmetal and nonmetal. Hydrogen bond is actually not a bond. It's an intermolecular force. Again, we'll get there later. And metallic bonds happen between metals. So right now, at this point, we've only covered ionic bonds, metal and nonmetal, so therefore it is C. Okay, moving forward to number 10. Number 10 says compared to the calcium atom, the calcium ion has. Now, right off the bat, we can get rid of A and B. Remember, if you change the number of protons, you're changing the element. So we have calcium and calcium, so we can't change protons. But now it's coming down to electrons. And this +2, that means something. So remember, plus means you lose electrons. Electrons are negative. So if you're losing negative stuff, you become more positive. And then that number tells you the number of electrons. So +2 specifically means you lost 2 electrons. So that would mean the calcium ion has fewer electrons than the atom. If you're losing electrons, you're going to become positive, and you actually also become smaller. Okay. If you're a metal. So metals tend to lose electrons, become smaller, and become positive. 11 says as a chlorine atom becomes a negative ion, the atom will. So chlorine lives in group 17 and has 7 valence electrons. So what it's going to want to do is gain 1 electron from something, steal it from a metal, and have that perfect 8. So again, we know that it's even telling you that it's going to become negative. And you become negative by gaining electrons. So we can get rid of C and D. And if we think about it, if you're gaining an electron, so now, let's add that one. Come on. If you're adding an electron, you're now bigger. So when you gain electrons, your radius becomes A bigger. So gain electrons, increase radius. So that's the exact opposite of what we had said before. Metals, like on this question, metals lose electrons, become positive, and become smaller. Nonmetals become negative, gain electrons, and become bigger. Okay, number 12 says what type of bond is formed when electrons are transferred from one to another. This is very similar, if not the exact same, as one of the previous questions. Electrons being transferred, that is ionic, and so again, the answer has to be B. I think it's an exact repeat of a question. And there's only so many ways you can ask what kind of bond has transfer of electrons. Okay. Number 13 says when a reaction occurs between atoms with ground state electron configurations of 2-1 and 2-7, the bond formed is mainly. So don't get freaked out about this. 2-1, if you even just look at your last number, things with small valence electrons are metals. But even if you find this is Li, and that is a metal. 2-7 is fluorine, and that is a nonmetal. And what happens, metal plus nonmetal is, again, ionic. So another way you could look at this is that, okay, well, this has 1 valence electron, this has 7. This electron is going to move from that to the other, and now both of them will have those full stable valence shells. Okay, so number 14 says what type of bond is formed when an atom of potassium transfers an electron to a bromine atom. So again, transfers electrons right there is enough to say ionic, but it says bromine. Bromine we know is a nonmetal. Potassium is a metal. So metal, nonmetal, and the transfer of electrons, all of that says ionic bond. Okay, number 15. Number 15 says draw the electron-dot or Lewis structure of an atom of chlorine. So chlorine is Cl. So again, Lewis dot structures only have valence electrons only. So chlorine has 7 valence electrons. And so when you're drawing your valence electrons, like we had said before, one on top, one on the right, one on the bottom, one on the left, and then again, 1, 2, 3, and that's it. You're just drawing those 7 dots. This is your final answer. Okay, so this question is a lot of words, and it talks about fluoride in toothpaste and a whole bunch of other stuff. Guess what? None of it is important. All that's important is draw an electron-dot diagram for a fluoride ion. So fluoride ion, we're talking about F, fluorine. So fluorine has the electron configuration 2-7. Again, it's a nonmetal. So what's going to happen to the fluoride ion? It's going to become F minus 1. So again, that minus 1 means it's going to gain an electron. So negative ions, so nonmetals, whenever you draw a dot structure for a nonmetal ion, you're always going to draw 8 dots. So again, fluorine normally has 7, but that ion gains 1 more. So nonmetal ions always have 8 dots. And then add your brackets and a negative 1 charge. Again, that negative 1 charge means that 1 electron was gained. And that's what it is. If you were drawing a metal ion, so on the opposite side of the periodic table, metal ions are drawn with no dots to represent what they lost. They have brackets and a positive charge. So, for example, if we had calcium, the atom has 2 dots, but if we're drawing the calcium ion, you draw nothing but a brackets and a +2 charge, because +2 means you lose those 2 electrons. So metals have no dots, brackets, and a positive charge. Non-metals have all 8 dots, brackets, and a negative charge. Okay, so number 17 talks about rust, gives you a formula. Again, don't panic. All we really care about is this sentence right here. What is the name of Fe2O3? IUPAC, again, they're just trying to confuse you. That's the people that decided how to name compounds. So we know we have iron, and we know oxygen is oxide. but you have to check to make sure iron does not have multiple options. But if you see that it does, Fe has a +2 version and a +3 version. So we cannot leave it like this. We have to give iron a name. And so we have to do a little bit of math to figure that out. And again, we have Fe and O. We have 2 Fe's right there in our formula. We don't know the charge, we're going to leave it as X. In our formula, we have 3 oxygens. That's what this tells us. And we know oxygen is -2, so that's the charge. So if we move this over, we get 2x minus 6 equals 0. Add 6 to both sides. 2x equals 6, divided by 2, divided by 2. X equals 3. So what that x equals 3 means is that we're using the +3 version of iron. And to say that, you just do 1, 2, 3, like that. So again, you have to make sure your metal either does or does not have multiple states. If it does have multiple oxidation states, then you have to figure out which one it is. Okay. Again, number 18 gives you a whole bunch of information. So let's just read the question first, right here. It says, write the chemical name of the compound that produces red light. Well, we have to figure out what produces red light. If you skim through this, it says red light is produced by Y2O3. So we have to name Y2O3. So if you don't know what the element name of Y is, that is okay. If you look at your periodic table, Y is, I'm looking at how to spell it, is yttrium, so YTTRIUM. Again, comes right off of table S. And if you look at your periodic table, Y only has one option. So we do not need Roman numerals. And again, to name oxygen, you just write oxide. And that is it. Again, the reason we do not have Roman numerals here is because there's only one option for that metal. You only need Roman numerals, like in this version, if the metal has multiple charges or multiple oxidation states. Okay. Number 19 says the elements of group 17 are halogens, blah, 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 blah. Identify the type of chemical bond that forms when potassium reacts with bromine to form a salt. So again, let's look at the element classifications. Potassium is a metal. Bromine is a nonmetal. So metal plus nonmetal is an ionic bond. 2 words, that's all you need. Okay. Lastly, again, you're given this equation. It doesn't really matter. The question here, though, is explained in terms of electrons, why the bonding in NaCl is ionic. So again, when we talked about ionic, there's a few things that we need to know. Ionic bonds is a metal plus a nonmetal, and electrons are transferred. So when we're talking about this question, it says in terms of electrons, why is this ionic? So all you need to say is electrons are transferred. That's enough to get you the points. That's all you need. If you wanted to continue and say electrons are transferred from Na to Cl, that is also correct. If you want to say from the metal to the nonmetal, that is also correct. But get in the habit of just saying your answer in the fewest amount of words. Leaving it like this is fine. When you start writing other words, you open up doors and opportunities to make a slight mistake. So if you made a mistake and said from Cl to Na, even though you wrote that, the whole answer would have to be marked wrong because you said wrong information. So just keep it simple. Use as few words as you can. Electrons are transferred. Done. That's it. So that's it for this. Hope it was helpful. Good luck on the quarterly. Bye.